Okay, so in our lesson 1.10, we're going to deal with precision and accuracy and tolerance. And when you were doing your, kind of like your surveying of the lesson just a little bit ago, you really should have discovered some definitions for all of these. In your own words, I don't want the technical definition. In your own words, what is precision? If we're looking for something being more precise than something else, what are we really looking for?
Accuracy.
Okay, accuracy. Well, I'm kind of thinking that accuracy and precision each have their own meaning. So if I say to you, which is more precise, like there's our first example. Which is more precise, 4.33 grams or 4,337 milligrams? Which one is measured more precisely? How do we decide? Brianna? Which one is more detailed? And how do we know which one's more detailed? Maybe I should put it like this. If I say to you, you know, I'm going to give you $5 and some cents. Or I say to you, I'm going to give you $5.99. Which one's more detailed? Yeah, I'm telling you more specifically, and it's measured out to, you know, to a detail. Whereas if I just say $5 and some cents, it could be, you know, it could be really close to $5, it could be really close to $6, but I'm not really telling you to the exact cent how much I'm going to give you, am I? So when we talk about something being measured precisely, we talk about it being measured to the detail of what's the smallest, which one has the smallest unit of measure. So which one's measured to the smallest unit of measure? Now, here's where it gets confusing. Which one is smaller, milligrams or grams? Milligrams are smaller, but does that mean it's more precise than in this case?
No.
No, not because they're a smaller unit of measure. We have to look for which of those is measured to the smallest unit, okay? Which is, they mean two different things. So when we are determining precision, we may need to do some conversion to help us make a comparison. So does anybody happen to know how many milligrams there are, since they're the smaller unit? You said how many milligrams are there in a gram?
Just divide that. And use.
So if I want to take the milligrams and change them into grams, what would I do? Well, we could use a conversion factor. Remember our conversion factors? We would want what to go away? We want the milligrams to go away so that we can change it into grams and compare it to the other one. So we said there's 1,000 milligrams in a gram, right? So now we could say, oh, okay, well, the milligrams are going to cancel away. And I'm really going to have 4,337 grams divided by 1,000. So it looks like we divide by 1,000. So 4,337 milligrams is really the same as what? 4.337 grams. Okay? So we just renamed 4,337 milligrams as grams. Now we're going to say, the other one that's grams is measured out to what unit of measure? Out to the, what's this? Hundredths. This one is measured out to the thousandths. Which one's smaller? Which one's, yeah. So we would say thousandths is smaller than hundredths. So 4,337 milligrams is actually more precisely measured. We'll just say is more precise. So thousands is smaller than hundreds. If we take something out to the thousandths place, we're taking it out to a smaller unit. The further it's taken out, the more precise it's going to be. So the 4,337 milligrams happens to be more precisely measured. Okay, anybody get a question? Now, the thing we want to keep in mind is not always do we have to do conversions though. What if this had been written like, to start with, it had been 47, grams, let's say, and the other one had been 433 milligrams. Which one's more precisely measured?
433.
Okay, the 433 milligrams? Why? Okay. No. They're both taken to the ones place. Go ahead, Jonathan.
Milligrams is taken to the tens.
Well, no, they're both to the nearest whole ones unit, aren't they? There's no decimal, nothing behind the decimal point there. Well, so now they're both measured to the same unit of measure. Now we say to ourselves, which one is smaller than the other?
47.
No, which of these is smaller than the other?
Oh.
Which of those is smaller? Milligrams. So now we would say milligrams is the correct one this time because they both started out. We didn't do any converting. We just left it as it was, and we can see that milligrams is actually, and because they're both to the ones unit, we could look at it and say milligrams are smaller than grams. Now, the other thing we could do is do the conversion. We could change those milligrams into grams. Anybody know how we would do that? Milligrams into grams again, what do we do?
Thousand.
Times 1,000 or divide by 1,000? Remember what we did here? We divided, so we would actually move this back 3 places, and now we can see that milligrams changed to grams is really out to the thousands places. So you got to somehow be able to kind of make sense of what's really going on here. Okay? Okay, well the next one's kind of tricky. 67 minutes and 1 1/10 hour. Anybody think they know which one's more precisely measured? What do you think, Ricky?
67 minutes.
Okay, why 67 minutes?
That's smaller than hours.
Okay. Minutes are smaller than hours? Well, I'm still not convinced because it isn't which one's a smaller unit, it's which one's measured to the smallest unit.
Oh, that'd be
Because what about the fact that isn't hours taken up to tenths and the minutes is only to the ones place?
Yeah.
Oh, but be careful. Logan?
Like if you would change 1.1 to minute, 1 hour and 1. Oh man. You could change that to minutes, it would be 70 minutes.
No, it isn't. There's not 100 minutes in an hour. Go ahead, Devin.
If you change the hours to minutes, it'd be 66 minutes.
Okay.
Okay, and so the minutes that are already up there is 67. So
So now how are we going to decide between 66 and 67? They're both rounded to the nearest whole minute.
66 is smaller than 67.
It is.
So it's a smaller number of minutes. Yeah, this one's tricky. You know what? Let's draw a picture. First of all, let's decide what is, because I don't want Logan to think that 1/10 of an hour is 10 minutes. So 1/10 of an hour is really how many minutes?
6 minutes.
60 over 10, which is 6 minutes. Okay, so 1/10 of an hour is really 6 minutes. So if this one's rounded to tenths and this one's rounded to minutes, let's do it on let's have this round clock here. And I just want to go from 12 o'clock to 3 o'clock. How many minutes are there in that first interval of that first quarter of an hour? How many minutes are there?
15.
Okay, so we could draw this into 15 like equal sections, right? I mean, I can't probably do it, exactly, but are you getting the picture that those minutes are pretty small? Okay, but in this one, when we do it with the 1/10 of an hour, now let's do those 1/10 of an hours. Let's show that from 12 o'clock to 3 o'clock. Now we're talking about blocks of time. 1/10 of an hour is 6 minutes. So here is 6 minutes. Another 6 minutes. And then we got 3 minutes left over, don't we? Which one's smaller measured? The minutes, aren't they? This one, what's really happening in the 1 1/10 hour is it was rounded to a block of 6 minutes. That's a bigger unit. It was rounded to 6 minutes. The other one was rounded to nearest minute. And that's different. So let's put down here, just we kind of have our picture too. Let's say that 1/10 of an hour is larger than a minute. Because 1/10 of an hour is 6 minutes. And that's larger than a minute, isn't it? So which one are we going to say is more precise? The 67 minutes is actually the one that is measured more precisely.
Minute.
Okay. So that's kind of a tricky one. A little bit harder to wrap your head around, maybe. And if there were 100 minutes in an hour, then we could kind of start reasoning like Logan was. But since there aren't 100 minutes in an hour, we can't do that.
Well, that would be good.
Okay.
That'd be kind of nice.
Okay, what do you think in number 3? Anybody got any suggestions for us for number 3? I think we could do it this way. Because right now they're measured, one's measured in centimeters, the other one in millimeters. They're not both to the same unit of measure. Centimeters is taken out to the thousandths place. Millimeters, it looks like maybe it was rounded to the tenth place. So we can't compare them like apples and apples right now. They're apples and oranges at the moment. So we got to get them so that they first probably are in the same type of measure. So do you want the centimeters changed to millimeters or millimeters changed to centimeters? You make the call.
Millimeters to centimeters.
I think I like changing the centimeters. I'm going to go with Devin. Devin and I are going to do it this way. We're going to change those centimeters into millimeters. So we'll just put that over 1. What conversion factor are we going to use?
I don't know.
How many millimeters in a centimeter?
100.
No, that's in a meter.
10.
10. There's 10 millimeters in a centimeter. We need the centimeters to go away, so we'll put that downstairs. And the 10 upstairs. And we'll convert, and we'll see that there are really, what? 2.65, and those are now millimeters, aren't they?
Yep.
Okay, so now tell me which one is measured more precisely. Now that we have both in millimeters, which one's taken out to the smallest unit of measure? Devin?
The 2.65 millimeters, because it rounds to the nearest hundredth, and 260 rounds to the nearest one.
This actually rounds probably to the nearest 10, because when there's a 0 there, we have to assume that it possibly was rounded to the nearest tens place. So we would say that hundredths, not hundredths, because it's 2 places behind the decimal, hundredths is smaller than tens of centimeters. So 0.265 centimeters is more precise.
So when in doubt, go with the smallest one.
No, that would not be a good theory to follow. Because actually, in this case, millimeters are smaller than centimeters, aren't they? So why didn't we go with millimeters? I don't know. Let's try number 4. Go ahead and try number 4 on your own.
This.
I think, first of all, they both measured out to the same unit of measure right now. Don't even care what they're measured in. Are they measured to the same unit?
No.
No. So you cannot do well, this one's milligrams are smaller than grams. You can't do that. You got to do a conversion problem. So go ahead and convert, and then make a decision here. Anybody happen to know how many milligrams are on a gram, by the way? Okay, thanks. I did both conversions, you only really had to do one. What happened when you converted? They're the same. So is one of them more precise than the other then?
No.
No, sometimes it's neither. It doesn't matter. They were both, one measured as precisely as the other. Now, that's because when we converted them, they are to the same unit, not because they look exactly the same. It's because in this one, this is to the ones place, and after we converted here, it's to the one place. That's why they're the same. And same thing here. After we converted, it was to the thousands place, and up here, this one was to the thousands place. That's why we would say neither is more precise.
So couldn't you just put 33 milligrams is equal to 33 milligrams?
Not really, because it isn't the fact that they're equal to each other. That's what I was just trying to say. It's not because they're equal to each other. It's because even after you converted them, they're now both out to the same unit of measure. So if one of them would have turned out to be 35 milligrams and the other one 33 milligrams, we still would have said neither because they're both measured to the ones place and they're both milligrams.
But then, wouldn't it be 33 because it's smaller than 35?
Nope, you don't go with how much there is of it. Not by how much there is of it. It has to do how it's measured only. Okay?
Okay.
It's tricky. Precision is tricky. Any other concerns before we move on to our next term and skill in our lesson? Okay, then let's go to the back side. Now we're talking about accuracy. What did you learn about accuracy? How is accuracy different than precision? Precision, remember, is measured to the smallest unit of measure. Ricky, what's accuracy then?
Measurement that is the closeness of a measured value to the actual or true value.
Okay, so in other words, there's an ideal, what we want it to be, but it doesn't always get to exactly that. It gets
No.
close.
It can get close.
Yeah, and sometimes you might measure it like 3 different times, and you got to pick out which one's the most accurate. The one that's the most accurate is the one that is closest to it. It's no different than if I said to you, I'll say to you, the person who's going to get the money in my pocket is the person who most accurately guesses how much money is in my pocket.
$12.
So, if I let you all have a guess, who am I going to choose to give the money to?
Whoever is closest.
Whoever is the closest to it. Whoever is the fewest pennies away from how much money I actually have in my pocket, which, by the way, is none. I don't have any money in my
Ha!
pocket.
I said zip.
Yeah, so accuracy means how close is it to what we want it to be, okay? So I want you to look on page 76. I want you to look through that problem number 2. Read through the problem, and then we'll work out the 2A and 2B here. Because there's a difference between precision and accuracy.
These are messed up scales.
Not really.
It has 16 ounces on top of it.
Okay, so in other words, what's the ideal in this problem? What do they want it to be?
The most precision or
16. They want the scale to be as close to 16 ounces as possible. To be considered an accurate scale, it has to be as close to 16 as possible. But if it is more precise, then it has to be what? To the smallest unit of measure. Okay, so which one's more precise? That's our first question. Scale A, B, or C? Which one's most precise?
B.
Why B?
Because it's the closest.
No, more precise means measure to the smallest unit of measure. That's
Yeah.
which one do you want?
C,
C, why C?
because it's rounded to the nearest hundredth.
Okay, and the other two are to the
Tenth.
10th place. So scale C is because hundredths of ounces is smaller than, and in your homework you have to justify all your answers. So that's kind of what we're doing here. We're justifying hundredths of ounces is smaller than tenths of ounces. So we say scale C is measuring most precisely. The next question is, which of those three scales is measuring the most accurately? And by the way, it doesn't have to be the same scale. Precision and accuracy don't mean the same thing. But which one is measuring most accurately, Brianna? Scale C. It just so happens that you think scale C is also the most accurate. Why?
Because it's only 0.07 ounces for 860.
Oh, okay. So scale C, we're saying, is the most accurate because C is how many ounces? It's, would you say 0.07 ounces off? Okay. Here's some justification, guys. Write it down. C is 7/100 ounce. Actually, it's not ounces. That's less than an ounce. So we would say 7/100 of an ounce off. B is how far off?
2 ounces.
2 tenths, isn't it? Is it 2/10 of an ounce off? Okay. And scale A is how far off? 3/10 of an ounce off. Okay. This is our justification. Get it in your notes. When you have to do these, you have to justify why you think the one that you choose is most accurate. And basically what we really do is just compare all three of those numbers. We say on the number line, what order would they come in? Well, 0.07 is less than 0 and 2/10, and that both of them are less than 3/10. So we are going to say scale C is the most accurate. So again, with guessing with how much money is in my pocket, if I had some in here, the person who guessed 7 cents away would be far more accurate than somebody who guessed 20 or 30 cents away, right? They should be the ones to get it. Okay. Any questions on accuracy versus precision? Okay, then let's go on to tolerance. Tolerance is kind of like expressed in a range. It's kind of like our absolute value problems, where we said there was an ideal, and then it could vary. It could be this much going to the smaller, and then it could be that much going to the greater. Then in other words, the ideal was right smack dab in the middle. But our tolerance ranges are going to be expressed as either the ideal plus or minus some percent, or they're going to be expressed as the ideal plus or minus the amount that it can vary by. Well, in our first one, and check it out, problem number 4, we're actually going to do 4A, and you're going to do C on your own in your SQ3R. So 4A, what's the ideal? I think it's written something like this. The tolerance range is 4.1 plus or minus 5%. Am I right? Okay. What's the ideal? And these are inches, if I'm also not mistaken. I forgot to put that. These are inches. 4.1 inches plus or minus 5%. In other words, what? What do they really want it to be? What do they really want it to be? 4.1 inches. But they'll tolerate it varying by as much as up to 5%. Have you ever heard of like voting? Have you ever heard that on TV when they say that this person has has 57% of the vote, give or take a 3% margin of error? So they're saying 57%, if it's exactly right, it's 57%. But we're giving it a margin of error of 3%, so it could be down as low as 54% of the vote, or it could be up as high as 60% of the vote. But in the middle is that 57%. Well, here they don't want us. They're not giving the first number as a percent. They're giving it as inches. So they're saying, here's what we want it to be. Here's what we want it to be, but we'll tolerate it going 5% that way or 5% that way. So we got to figure out what that 5% is. So anybody know what we have to do to figure out what 5% of 4.1 is? Brianna?
Multiply 5% times 4.
Okay, but how do we actually have to treat 5%?
0.05.
0.05. So we're going to take 4.1 times our 5% change to a decimal, because you can't do it as a number 5. Won't work out very well. And then I think it says in your book, it says to round to the nearest what? 100. Okay, so could you find out for me what is 5% of 4.1 inches?
0.205.
I think it's 0.
Yeah, 0.205.
One.
End up being
Yes.
1.
Which would round it to the nearest hundredth would be 21 hundredths, right? Okay, since they asked us to round in hundredths. Okay, well, that's saying it can vary by about a 21 hundredths of an inch. It can go 21 hundredths less than, so we can take 21 hundredths away from 4 1/10 inches. And we could say at the low end, we would tolerate a 3.89 inches. And at the high end, we would tolerate 4.31 inches. So the range of tolerance goes from 3 89/100 inches to 4 31/100 inches. That's our actual range of tolerance. Anything that falls in that range is acceptable. Okay. What's my range of tolerance for quiz scores?
75% or higher.
75% to
100.
100%, right?
Michelle's that good.
Yeah. 75% to 100%. What's the middle of that? Anybody know?
80,
85.
90,
87 point.
87.5, 87.5%. So
Somewhere
87.5%. Apparently, I think you're all capable of an 87.5%, but I'll give it down to 75% because I have to be a little bit tolerant, and then of course I'll tolerate up to 100% because I know that there are people who want to do well and overachieve. Okay, so you're going to do C on your own in your SQ3R notes, okay? So we're just going to do 4A. You can finish up the other check it out problems for that one. Okay, and then we're going to do rewriting specified tolerances as percent. So now you have to add a little subtraction sign under that addition, by the way, right there. 60 ounces plus or minus, add the little subtraction sign, I think it got left off. 60 ounces plus or minus 1.5 ounces. What are they really saying there?
You can add.
It can be 61.
It can be higher than 60, it can be lower than 60, it can be from one end to the other, right? Okay, so they want us though, instead of it, so it can go down to 58.5, you said, and up to 61.5?
Yeah.
But they don't want us they want us to write it as a tolerance with percent. So they want it kind of like we just came from, 4.1 inches plus or minus 5%. So we got to figure out what percent 1.5 ounces is of 60 ounces. How are we going to do that?
Take 60 divided by 1.5.
Hey, what's 60 divided by 1.5? 40. Do you really think that 1.5 is 40% of 60?
No.
That doesn't seem very reasonable, does
Yeah,
it?
then you get multiplied by 100.
And then you're going to multiply by 100 besides, well, then that's 4,000. So you think,
Perfect.
so we got to divide it by, no, so you guys are going the opposite direction.
So 60 divided by 100
No.
times. Oh.
Well, let's do this. It's kind of like a quiz score. I hope this never happens to any of you, but it's like the quiz score was 1.5 out of 60 points.
I haven't done that bad. I've done pretty bad.
So what do you do when that's what you get on the quiz? What would you do?
You take it.
1.5, the part you got, divided by the part you could have gotten, and then multiply it by 100 to change it to a percent.
2.5.
So it's 2.5 or 2.5%?
Yep.
Does that seem more reasonable? That 1.5
Good.
ounces is about 2.5% of the whole 60 ounces? We're talking about 60 ounces and only 1.5 of that. Yeah, I think that seems far more reasonable.
I get the other.
Now what we do is rewrite the tolerance with the percent rather than the variance in ounces. So we say, oh, here's what we really want it to be. We want it to be 60 ounces, but we will tolerate plus or minus 2.5% of that 60 ounces. So now we're rewriting it as the percent. Okay. Any questions on that?
What on earth is happening to my pencil?
Okay.
Yes, 2 pieces.